This is a question on optimization, mathematics grade 12, paper 1. A drinking glass in the shape of a cylinder must hold 200 milliliters of liquid when full. Determine the value of R for which the total surface area of the glass is a minimum. That is what we need to do. Now, to answer this question, the understanding that we need is that at the minimum or maximum, the derivative is always equal to 0. At the minimum or maximum, the derivative is always equal to 0. At the minimum of anything, minimum distance, minimum height, maximum length, maximum volume, maximum surface area, at the maximum or minimum, the derivative is always equal to 0. So to answer this question, we must formulate an equation that represents the quantity that you want to minimize or maximize. In this case, we want to find the maximum of the surface area of the cylinder. Therefore, we must formulate an equation that represents the surface area of the cylinder. And the equation is formulated using the formulas that we already know. We know that the surface area of a cylinder is 2 pi r squared plus 2 pi rh. In some examination papers, they give you these formulas, so it won't be much of a problem. But the thinking is that we must formulate an equation that represents the quantity that we want to maximize. We want to maximize the surface area. Therefore, we need an equation to represent the surface area of the cylinder. Surface area of a cylinder is equal to 2 pi r squared plus 2 pi rh, where r is the radius and h is the height of the cylinder. Then secondly, so by doing so, we have done number 1. Secondly, we must differentiate this equation and equate the derivative to 0. But before we differentiate, we must make sure that our equation has one variable only. So we want to differentiate. If we look at our equation right now, we have different variables. There is r and there is h. So because of that reason, we are not able to differentiate the expression. Now, in that case, it means you must formulate another equation using the information provided. Then you substitute into the first equation to make sure that your equation has got one variable only. In this question, we are told that this cylinder must hold 200 milliliters of liquid. That is the volume of this cylinder. And we know that the volume of a cylinder is equal to pi r squared times the height. This is the volume of a cylinder. So using the formula for the volume of a cylinder, we can formulate another equation that will help us substitute into the first equation so that we can make sure that the variable in our equation is 1, not 2. We need to express the equation in terms of r only or in terms of h only. Now, doing that means the volume of a cylinder is pi r squared h. So in place of the volume is given. It is 200. Therefore, we're going to equate pi r squared h to 200. Then from there, we make h the subject of the formula. Dividing both sides by pi r squared, h is equal to 200 over pi r squared. Then carrying on. Now, in our first equation, the surface area has got h. So we have made h the subject of the formula here. It means we can remove h in our equation and replace it with 200 over pi r squared. Now that gives us our formula or our equation for the surface area in terms of r only. So we have substituted, you remove this h here and replace it with 200 over pi r squared and simplify the expression to simplest form. Once it is in its simplest form, then we can differentiate it. You differentiate. After differentiating, equate the derivative to 0 and solve the equation. So if we differentiate our equation here, remember our surface area in simplified form here is 2 pi r squared plus 400 over r. So we have to express this r as r to the power negative 1 so that we may be able to differentiate it. After differentiating, we equate the equation to 0 and solve to determine the value of r. So in this case, r is equal to 3.99 centimeters. The question is solved for 6 marks. So just to quickly go through the steps again, you read your question to understand it. Then number 1, formulate an equation that will represent the quantity that you want to maximize. If your expression has more than one variables, you formulate another one. Then you integrate those two equations together and simplify to simplest form. After simplifying, to determine the maximum or minimum, we differentiate, equate the derivative to 0, and solve for the given variable. That will lead you to the answer that is required for that particular question. Once you do that, your optimization question is answered.